Right. So, good morning, everyone. Uh, so there is a small change in the session which we were supposed to have today. We originally planned to have the complete React.js testing, testing React.js components and React.js applications as the primary topic for today's session. We are slightly changing that because today, instead of that, we are actually starting off with Redux basically. The reason for this change is that if we were to try and attempt doing the testing in React.js after the basics, then we will have to take a small break and then visit Redux and Redux Saga. And then again, the testing for Redux and Redux Saga is going to be somewhat different. So we would have to visit testing in so many different levels. Also, there are different kinds of applications which we will be testing. So we thought it would be beneficial if we could cover the testing of different kinds of React.js applications all within the same session or within consecutive sessions. So that we can actually understand not in bits and pieces, but as a whole, what are the different kinds of React.js applications or what are the different designs that are out there and how we can write test cases for these different designs. Okay, so that's the reason that we actually wanted to cover Redux and Redux Saga first, and then get into testing React.js applications. Okay, so I hope that's all fine with everybody. Okay, so let's start off with today's session then. Uh, so basically, let me first understand from all of us, how many of us are already familiar with Redux, with Flux, or any of the Flux frameworks which are available? If you are not aware, then type no in the chat message. If you are aware of any of these frameworks, type the name of the frameworks which you're familiar with. And also, I'd like to know whether you have used this in a project or whether you have only learned it. Okay, so we have about 4 of us who are already familiar with Redux, and we have about 3 messages saying that we are not familiar with Redux. Okay, another question is, do we know how to perform immutable operations, all of us? So if you know how to perform immutable operations, then please type yes, otherwise say no. Okay, awesome. The third question is, how many of us are familiar with um, reduce operation on arrays or with reducers in general, or the functional programming concept of reducer? Anything, any of these. If you know how array.reduce works, or if you know how reducers work, or if you know any functional programming language and you know about reducers from there. So if you know a reducer, type yes. If you don't know, just type no. Okay, right. So I think let's also visit reducers for the benefit of some of us who are not familiar with it. But yeah, we could do that. First, let's get an understanding of what Redux is. Specifically, uh, what are the core concepts of this Redux? Okay, and then we'll get started with some of the examples. And let's start with some of the smaller examples and start using Redux within a good application. That okay. So so one of the important things is not really core concepts. We'll actually look at the three principles here. Okay, so one of the principles which Redux, you know, you need to follow while using Redux is single source of truth, right? So first of all, Redux is used for state management within our application. So all the data that is required to render the right page within the application, uh, this is actually part of the state. Okay, so state could be an in-memory object, it could be something which is stored inside the local storage, or it could be anything. So basically, it's a JSON, right? Also, going back to the concept which in module one we had discussed in one of the sections, that to build UI application, there are four things which are important. Okay, so the first one is basically the views. What views do in no particular order. Okay, so views is one of them. What views do is they take model, and so basically views is a combination of a template and a model. Okay, so given some model or given some data, when we combine it with a template, we get a view. We get a visual representation of a portion of our application. So that is called as a view, right? The second thing which we have to take care of while designing UI applications is about the controllers. Okay, controllers are those elements which actually detect changes within the application, either user interactions or something on the server that has changed and which is being pushed to the client side. Okay, so controllers is the second thing. The third one is services. Okay, so what happens in services is if we would like to pull data from either our server or any of the third-party applications, then we write them as simple functions, simple reusable functions, which we call as services. Okay, and finally, state management. So state management is necessary so that instead of having two-way data, two-way changes. So for instance, we have a state, we have a view. When the state changes, the view has to change. And when the view changes, the state has to change, right? So when would a state change by itself? When the server makes some change, or when the server notifies the client side of some change, the state changes, or the user has interacted with the application and the state changes. And accordingly, all the other views which are working with that state, they get updated, right? This is one direction of data flow. And the second direction of data flow is the view directly changes and then the state has to change. So this usually happens whenever a user interacts with your views, like if there is a form element or if there is a button or any of these things, right? So whenever any change happens, basically we have to ensure that both the state as well as the views are updated properly, right? So this is one of the concerns for state management, right? So what Redux does is Redux says that there is a single source of truth uh, for the state within our application. Okay. Now, because of this, because of saying that there is a single source of truth, the implications are actually very interesting. So, for instance, when we say that there's a single source of truth, it means that there is a JSON object, or there is the entire state can be stored within our local storage. okay, or it can be assigned to a single variable, right? And it basically makes it very easy for us to work with the application. So basically what happens is there is a state, and all the changes to the state happen in the form of action. That is actually the second principle. Okay. Uh, so because of maintaining state in one place, we have lots of advantages. So one of the things is we have a undo or redo capability that is very easy to implement. Okay, because think of it like this: within Trello applications, we have moved the cards, we have created new cards, moved the cards, and so on. If you want to undo the operation which you did, it is as simple as taking the current state and replacing it with the previous state. Okay, so every time the state changes, we can push that into an array, right? And every time the user says undo, then we pop the state from the array, and then we use that as a current state. So undo redo, for instance, becomes very simple. We can persist the app state. Okay. In this example, he says in development, so that whatever state that we had created after several user interactions, that state can be persisted, it can be serialized as a JSON, it can be shared, and so on. So many other things that we can do because of it, right? And yeah, so they also mentioned that it becomes easy to debug and inspect the application. Okay, because the entire application, the entire view is actually generated from the state. We'll see that in some time, right? So state basically has a single source of truth. The second part is that state is read-only. Okay, so whenever we have a state, right, we are not allowed to make any changes to the state. Okay, so the developer is not allowed to make any changes to the state. Rather, the way we have to code is that we emit an action, okay, and this action describes what is happening, and this action determines what is the next state. Okay, so we are not allowed to change the state, right? You can also interpret this as saying that, number one, you're not allowed to mutate the state outside of the store. So we are going to create a store, a Redux store, which keeps a copy of the state, of the current state. Okay, so within the rest of our program, we are not allowed to change the state at all, right? Rather, we emit an action which automatically changes the state. And we have to program the store in such a way that it expects certain actions, and it describes exactly what change needs to be done in the state. Okay, and the final part is changes are made with pure functions. Okay, rather these pure functions, which normally describe what changes need to be done to the state, these are called reducers. Okay, so let's quickly get started with reducer. We will revisit these points again, hopefully at the end of the session, so that everything falls into context for us. Right? So let me just open a blank page, about blank. And start with, let me just open the sources.
Sagar, we are not seeing your screen.
Oh, okay. 1 second, let me share it. Okay, now can you see it?
Yes, sir.
Okay. So the three principles which I shared, they can be accessed from this website, redux.js.org, which is the official documentation, official homepage for this Redux, right? Click on Getting Started, and here you can find under Introduction 3 principles. So this is what I described so far. Okay, single source of truth, the 3 principles: single source of truth, state is read-only, and changes are made with pure functions. Okay, so I just opened this blank page, and let's look at first. Let's look at what a reducer is. Okay, now a reducer is a kind of function. Okay, it is a function with a certain signature and a certain behavior. Okay, so what is the signature of this function? So this function basically takes two arguments. The first one is the what you can call as current state. Okay, and the second argument is called the action, right? And it returns new state. Okay, this current state is a serializable object or JSON. New state is a serializable object or JSON. Okay, sometimes it's okay to violate the rule of serializability, but try and avoid it as much as you can. Okay, only store data, only store state within your current state. Don't store things like socket connection or any live connection within the state, right? So this is the signature of the function. Okay, and what is the behavior of this, of a reducer? So the behavior of the reducer is uh, given a current state and given an action, it returns a new state by making changes in the exact same in the current state. Okay. Now this current state, for instance, if you take a to-do application, the current state could include the items which are part of your to-do list. Okay, so it could be an array where there is item 1 and there is item 2, right? And now an action could be, again, it can be represented as a JSON, which describes what is happening. Okay, so it describes the action type as being add item, and the item would be item 3. Okay, so when you let's write a reducer which is going to change the state. So to do item reducer, the signature for this is current state and action, and it returns something. Okay, so what I would do is I would first check if action dot type equals add item, then return uh, current state dot push action dot item, else return current state. Okay, rather here what we are doing, push doesn't return anything. Okay, this is how we write a simple reducer. So once we say uh, okay, let me call this as current state. Let me call this an action. Okay, and then we are saying to do item reducer current state and action, which will return a new state. Let's log this new state. So if you see, new state is now printing the 3 items. Okay, so this is basically a reducer. We have written a reducer which describes uh, the transition between an old state and a new state because of a certain action, which is caused because of a certain action, right? Now, this is a simple reducer. There are a few laws or few uh, rules that we are violating here, but this is the basic thing what a reducer does. It gives you transitions. Okay, so yeah. Now, one of the places where reducer is normally used is, an array has a reduce function. Okay, let me comment this portion out. Right? Normally, this is used in array. So, for instance, uh, if we have an array of items where we have, let's say, a bunch of numbers, right? And we want to calculate the sum of all of these numbers. How do we do that? So every array has a reduce operation, okay, inside which we define a reducer. Okay, the signature of reducer, again, it takes 2 arguments. Okay, it takes current state and it takes action. Right? So I'll use a different names for these variables. Okay, remember the signature has to be fixed. The variable names could be different. So I'll use a different naming convention here. I'll use accumulator and I'll use item. Okay, now what happens is, first there is an initial value which we are giving here as a second argument. Okay, first the current state, or first the accumulator, has this default value of 0. For each one of these items, this reducer is applied and a new value is determined. Okay, so if we were to write it here, let's see how it looks. Let me copy all of this. Okay, the accumulator is 0. So let me put that at the beginning. And these are the rest of the items. Okay, this is the initial state, or 0 is the initial accumulator, and these are the items within the array. Now, what this array.reduce operation does is, it takes the combination of this accumulator and each one of these items iteratively, and it passes it to the reducer. And the final value that is calculated is returned by this reduce operation. So, for instance, it will basically do apply the reducer to 0 and 1. Okay, and the remaining items are these. Okay, this is what happens during the first iteration. During the second iteration, it will take the value of this. So what is the value of 0, 1? Here, since we want to calculate the sum, we can return accumulator plus item, which is 0 plus 1, right? So the value which we'll get is 1. Now for the second iterator, we will apply this reducer with 1 and the next item 2. And the remaining items are these, correct? So 1 plus 2 is going to be 3 and 3. So the remaining items would come here. And now we have 6 and 6. And the remaining items will come here. And so on. Okay. So 12 and 4. This is 16 and what, 9? 16 and 0, right? So we'll get a 9, 16 and 9. And there are no items left anymore. So the final value would be 25, right? So this is going to return a number, sum, and if we log sum, then we will get sum as 25. Okay, so this is how we use reduce operation to reduce a number of values into a single value. Okay, so we have written a reducer, we have written a reducer, and we have defined what is the default uh, accumulator value. And this reducer takes an accumulator value and one item from this list or from this array, applies a reducer on it, and it does it recursively for all of these items. Okay, so that's how we are basically calculating sum. Okay, this is one of the ways in which we can use reducer, but we will not be using reducer to calculate sum or to calculate any kind of aggregates, right? We will rather be using this to model our state transitions. So given a state and given an action, what should be the next state? Okay, so that is what we will be modeling basically. So let me start this uh, within a project for now. Okay, I'll use create React app and give it a name like Trello app. And open this in the editor, right? So okay, this is the wrong place. Trello app is the right place. Okay, this is a typical React.js application. So it's created from create React app. Let me delete all the unnecessary files and work with index.js for the time being. Okay, so this is the hello React.js. This is a very simple uh, hello world program for React.js. Okay. What we would like to do is, first of all, we would like to write our reducer. So inside src itself, I'll create another file uh, and I'll call it uh, to do app or to do app.js. Okay. So what is my to do app.js? To do app.js is basically something which exports a reducer. So it is a function which takes two arguments, current state and an action. Right? Now, let's first identify what actions we can perform on a to-do application. Okay. So the first thing which we can do is we can add item. The second thing which we can do is we can mark item as complete. The third thing which we can do is what? Remove item. Okay. Edit item, something which we can do. Right? We can also move an item. So we can reposition items. So it's up to us to define what actions we would like to support within this application. So let's also support mark item as or unmark or okay, just mark item as incomplete. Okay, the opposite of mark item as complete, right? So let's just look at these three actions which can be performed on our to-do application, on our to-do list, and write a reducer for it. Okay, one of the simplest way in which we can write a reducer is by using switch case. We will switch based on action dot type. Okay, so for add item, let us take the JSON as being type add item. Then we can have payload as text item 2. Okay, so we are adding this payload or we are adding this item. Okay, similarly, we can have for this type mark item as complete, payload as, we'll give the item ID. Okay, item ID is 0. So whichever item ID is 0, we want to mark that as complete. Okay, again, it's up to us to define what is the JSON, what is the structure of this action, right? So mark item as complete is going to be something like this. So payload ID. Okay, so in move item, we are saying the item which has an ID of 0, its new index should be 2, right? So this is how we have defined our actions. And what will we do? We can write a reducer for each one of these. So we can say function add item reducer, which takes in the current state and the action, and say if action dot type equals add item. Okay, then what should we do? We'll add item to the very beginning. Okay, now last time what did we do when I showed the example in the browser scripts? We did something like this. Current state dot push, and then we said text item 2. We pushed only a string, but now I'm choosing to push an object. I'll generate an ID also. Okay, math dot random, multiply it with something, and add it with an empty string, so it becomes a string. So I'm generating a random ID, and I'm giving text here. Okay, this is what I'm pushing. This is what we did last time, something similar, only it was a string. Now I'm using a object, and return current state, right? Else we are returning current state. Correct? Now the thing is, whenever we are using reducer, there is a principle. The third principle states that changes are made with pure functions. Okay, so what exactly is a pure function? How many of us already know what is pure function? If you know, you could maybe unmute yourself and describe what a pure function is, or type it in the chat messages. Otherwise, type no, so that I get an idea of how many of us are already familiar with pure functions and or not. So what is a pure function? No side effect. Very good. So side effect is something which makes change in the environment. Okay. So thing like inside a function, if you do console log, that's a side effect. Okay. The reason being that in the function, you're actually accessing your std out, and you're emitting a value inside this. So std out is not local to your function. It's actually an environment provided stream, right? So that process has the std out, and the function is accessing something which is outside of its scope, and it is making changes to it. So that's why doing something like a console.log is a side effect. Okay, so it should not have side effects, not changing the actual data ever. Okay, so yeah, so what this means is that we are not allowed to change any data. So current state or action, uh, these are variables which are being passed to the functions. We should not be changing them. Okay, so when we say current state dot push, we are actually changing this current state array, right? So something like, or we are actually mutating the array, which is in turn changing an existing array, right? So current state dot push is not allowed. Okay, uh, doesn't cause re-render. Okay, we haven't gone till React.js yet. Uh, yeah, we haven't gone till React.js yet. So in terms of pure function, uh, I'm not sure how this fits in. Ganesh, would you like to explain this a little more? Okay, data change will result in re-render. Uh, okay, we'll look at that. Okay, so there are cases it is possible, especially in performance optimized React application, that data change can act, uh, okay, may not always re-render. It might have a new variable, or No, it's kind of correct. So yeah, Ganesh, what you said is right. Okay. But what we are speaking is only in terms of functions and pure functions, basically functions, right? Not pure components per se. Okay. But what you said is perfectly true when it comes to pure components. Functions with no another function call. Uh, okay. In pure functions, other function calls are allowed as long as even those functions are pure. Then the current function is pure. Okay. Immutability. Yeah. So these functions have to be immutable. So basically the same thing as saying not changing the actual data, right? So what we are doing here is we are changing our array, the old array. So for instance, let's say our initial state is an array of objects in which there is already an item. Okay, and we say current. We say add item reducer, and we pass an action to this. The same action will pass whatever is here. Okay, what will be the output if I run this JavaScript? What will be the output? Okay, two options. Will these two be same or will they be different? Old state and new state. Will they be same or will they be different? Type same or different. Yeah, this is the program. We are logging old state and new state. Will it be same or will it be different? I'm waiting for your responses. So please type whether it will be same or different. Okay, so let's run this and check. So what happened? Old state has two items in it, and new state also has two items in it. Okay, they are actually same. They are not different. The reason why they are same is because we are actually mutating the current state, which is what data has been passed from outside. We are making changes to that array by saying array.push, right? So current state and old state are actually same. They are actually identical. Okay. So how do we check? Uh, how do we ensure we create a new array without mutation? How do we? So yeah. So basically, ES6 provides us a mechanism of doing that. Instead of saying current state dot push, what we will do is we will return a new array. We will copy all the items from the old array, which is current state, current state. Okay, and we will add one new item, and this one new item is this item here. Okay, Now, if I were to run this program, the old state and new state will be different. Okay, because right now what we are doing is we are not mutating the old state. We are creating a new array. Okay, we are creating a new array. We are copying all the items of the old array into this new array. And then we are adding one more item into the array. Okay, so this is basically the ES6 spread operator. Okay, so yeah, so this is basically what happens. Now, we have to remember to, always uh, perform immutable operations. So whenever we are returning a new state, it has to be a new object. It shouldn't be an existing object's value changed. It shouldn't be that. Okay, it should be a completely new object altogether. Now, one of the other conventions that we follow within while designing reducer for Redux is that uh, instead of having an array as our state, this is basically not very useful. Of course, we can write entire applications using array as our state, right? But there are certain other constructs, other libraries which assume that the current state is actually an object, right? So in this case, what we will have is we will have items present inside the object. So this array is present inside the object like this. Okay, so now it makes our life even more difficult. Okay, this was easy. Creating a copy of an array was easy. But how do you create a copy of an object? Okay, this is little tricky, right? So how do we do this? First of all, so in order to work with a state like this, here also the current state will be in a similar object fashion, right? So first of all, let's take items. Old items equals current state dot items, right? And first let's create a copy of this new item. So const new items equals old items, and then add the new item. Okay, so we got a copy of this, right? Now we have to make a copy of this outer object, right? How do we do that? So for this, we will first take so new state equals, what we will do is we will use object dot assign. Okay, I'll describe what happens first. So first of all, in object dot assign, uh, what we are saying is create a new object, or take this object. The first argument is where I'm creating a new object, new empty object. Okay, then I'm saying copy all the properties of current state to the new object, right? And finally, I'm saying copy all the properties of this object, the third argument's object, which includes items as new items, and copy all the properties of this object into the first object. Okay, so object.assign is used for assigning the properties of different objects into a target object. So this is your target object. The first argument is a target object. Then it copies all the properties of current state into this target object. And finally, the third argument. So it copies all the properties of this object into the target object. Okay, so in this case, if your state had something else also, like the current view is your dashboard view, for instance. Okay, then this data still remains unchanged because here is the new object. It copies all the properties of current state, which includes items and current view. And then it copies all the properties of these objects, which is items, new items, into the state. So only this portion changes, right? So now let's run this and see. Okay, new state is undefined because we are not returning it. Right? So the old state has an object which has items and current view. Items is basically an array. And new state again has another object inside which items is an array which has two things now. Okay, text it says is undefined. Payload, okay, action dot payload dot text. Okay, so the new state basically has this part, which is items, which is an array of two items here, and the current view. Right? If you write something like this, instead of writing this, what is a mutable way of doing it? Mutable way is saying current state dot items dot push, and then say push this part. And return it, of course. Right? You will notice that the update happened for both the old state as well as new state. Okay, because this is mutation. The current state items is an array inside which we are pushing. So even for the reference of your old state, the data gets updated. The object gets updated. This is the object is mutated basically. Right? So we have to make sure that we don't mutate the object. Now remember, when I said that, implementing certain features becomes simple. Okay. For instance, if you want to implement undo or redo, what can you do? Every time a new state comes, you can push it inside your states array. Let's say you have states as an array here. Okay. And every time you call this reducer, new state, you're pushing this inside states array. Or let's say you're pushing the old state. Right? And now you have gotten the new state. Okay. So suppose you want to do undo. What is it that you have to do? You have to do states.pop. And assign it to current state. So current state can now has to be let. Okay, whenever you do pop, whenever you do undo, this is the code that you'll have to write. Okay, so what is it doing? It's actually replacing your new state with the old state or with the previous state. Okay, if you perform mutation, then the old state and new state is going to be same. So undo operation or anything like that is not going to work. Right? So that is why it is very important to ensure that every time you are performing immutable operations inside your reducer. Okay, so if it is an array that you would like to change, then use the array spread operator. If it is an object you would like to change, use object.assign. Okay. Now quickly let us write a proper uh, reducer, a proper to do application completely. The reducer, this reducer, let us write it properly now. Okay. So what would the code be? I would remove this code. Okay, so this is the code I've written for add item. This is an add item reducer, correct? I'll remove the states also for the time being. I'll remove all of this code. You get the point, right? Of current state and new state. If you perform immutable operations, then they are going to be different. If you perform mutable operations, they are going to remain same. Okay. So Soumya, we'll come to this. Okay. This is actually not a standard. We'll discuss this. Right. So let's write another reducer for. Okay, I'll remove all of this part now. Okay. So mark item as complete. I'll write another function here. Same signature. If action dot type equals then we are going to say uh, const old items equals current state dot items, and then const old item equals, this is the item which the user has passed, which has the ID of 0, okay, which is the first item. So I'll just convert this into a string because normally IDs are strings. So I don't want to rewrite the code again. So let me convert this action to 0. Okay. So const old item equals old items dot filter. So I'm filtering the items in which the item ID equals action dot payload dot ID. So I get the item which has to be marked as complete. And now I'll replace this with new item. Okay, so new item equals, we would say object dot assign, because old item is a object, correct? Create a new object, copy all the parts of new item, and then say uh, complete is true. Okay, so we got the new item. Now what should we do from this old items? We have to replace the item with ID 0 to a new item, correct? So how can we do that? We can do that with map. New items equals old items dot map. Okay. For every item, we are going to check if item dot ID equals to action dot payload dot ID. Okay. So if this is equal to action dot payload dot ID, then we have to replace it with uh, the new item. Otherwise, I. Okay. So we get a bunch of new items, and now this new items is what we have to place it within the current state. So we are going to return object dot assign new object current states properties, and then replace items with new items. Okay, so let's see an example. Else, let me also write an else. Else return current state. Okay, so const current state equals, let's say, items is an array which has ID as 0. Do I have current state here? Yeah, current state is already available here, right? So need not write it. Action I'll have to write. So const new state equals mark item as complete, then take the current state and take the action, which is this part, and log new state. Okay, let me also log the current state. Okay, so you can see that old state has one item with ID 0, text as item 1, and new state has item with ID 0 and ID 0, text item 1, complete true. Oh, hold on, something is wrong. Something is wrong. Items, so old item is current state dot items. Okay, so old item equals old items dot filter I such that I dot ID equals action dot payload dot ID. So we got the old item, and the new item is object dot assign empty object old item complete true. Oh, hold on. So this old item is actually a array, an array of all the items which are matching this condition. Okay, so I want to pick. I know that there's going to be one item in this array, so I'll select this of 0. Okay, so I specifically select one old item. Okay, and now if I run it, you can see that in the old state, this is what you get, and in the new state, this is what you get. So the difference is the item has uh, complete as true. So just to follow good practices, I'm going to say is complete. So just by looking at the property, we know that it's a Boolean, right? So the code actually looks a little bit complicated, but once you get used to it, no, this is actually one of the most predictable ways of writing your code. Predictable in the sense we are not doing any sort of mutation anywhere. So if you see old items, no matter where in this code you access old items, its value is going to be remain same. Okay, because we are not mutating anything within this function. Okay, so initially, since we are used to imperative programming, it seems a little bit unnatural for us in the beginning. But once we get the hang of it, right, a hang of using object.assign and using uh, the array spread operations and this array.map, okay, then it makes it easier and easier for us. And this is more, kind of functional programming. This is not so much as imperative programming. Okay, so let me just take questions here. There are lots of things yet we need to cover within this, but let me just give a small break and see if we have any questions that need answering. Specifically here, did you understand this code? Did you understand this code that I've written, or no? If you haven't, then it's good we can revisit it. Otherwise, it becomes a little bit confusing later on. Okay, so Anand has understood. What about others?
Sagar, your voice is not audible.
Yeah, is it audible now?
Yes.
Is it audible? Yeah, okay. So, any questions you have, you can ask me those questions, or yeah, I think ask, just type the questions here. I'll just look at it in a few minutes. Until then, let me continue with the coding. So, any questions you have, please ask there. I'll visit that in some time. So, mark item as incomplete, current state, and the action. If action dot type equals mark item as incomplete, then return. No, then we have to make these changes, right? So const old items equals current state dot items, const old item equals old items dot filter I such that I dot id equals action dot payload dot id. Take the first item from this array. Const new item equals object dot assign an empty array. Then old item, and then the new item, which will have the status or it's complete as false, and const new items equals an array of old, no, sorry, map. Old items dot map I such that if I dot id equals to action dot payload dot id, then it should return new item, else it should return I. Then we are returning the state object dot assign new object, copy the props of current state, and then items, new items. Okay, very similar to mark item as complete. Okay, so remove item, which is function remove item, current state, action, right? If action dot type equals remove item, then const old items equals current state dot items, const new items equals old items dot filter I such that I dot id not equals to uh, action dot payload dot id, const new state, or we can directly return object dot assign current state, and then have items new items, else return current state. Here I forgot to write else. Right, then we have edit item here, function edit item current state action if action dot type equals edit item, old item equals current state dot items, plural old items. Old item equals current state or old items dot filter I such that I dot id equals action dot payload dot id, and I know there's going to be exactly one item, so 0 new item equals object dot assign an object, then old item, and then say is complete. No, sorry, this is not, we are changing the text here. So text action dot payload dot text. Okay, else return current state, right? And finally move item function move item current state action. How do we implement something like this?
Sagar, it looks like edit item is not complete, no?
Yeah, 1 second. So we created new item, right? Now what should we do? Object, yeah, return object dot assign empty object current state item new item. We need new items, so yeah, const new items equals old items dot map I such that I dot id equals action dot payload dot id. Then we have to return new item, else we have to return I. Okay, now it's complete. I just forgot that part. Action dot type is move item. Then first we will get hold of the item. Okay, so const hold items equals current state dot items. Then const old item, or not old item, just the item. We are not changing it. So the item equals uh, old items dot filter uh, okay, so we need the item, we need the new list also, so we'll do that. I such that I dot id equals action dot payload dot id of 0. Const other items equals old items dot filter I such that I dot id not equals action dot payload dot id, right? So this is the item, these are the other items in the proper order. Now what we have to do is we have to construct new items, which is basically uh, an array with the spread operator for, okay, then let's do one thing. Let's calculate left and right. Left items equals other items uh, dot slice, okay, from 0 onto action dot payload dot index, right? Const right items equals other items dot slice action dot payload dot index plus 1 to the end of array, right? Then const new items equals left items, item, right items. Okay. Then return object dot assign new object, current state, and uh, items, which include new items. Okay, so this is how we implement the move item. So I didn't actually check this part, whether this is proper or not. We can do that at the time of writing test cases, unit test cases for this reducer. Okay, that will do the check for us very easily, right? So let's see, what have we written? We have written individual reducers for each of the action type, correct? But the entire to-do application, we need a single reducer. Oh, what did I do? Yeah, there's some glitch. Yeah, what's happening? Okay, so what we can do is we can use all of these reducers and write them within the switch case here. So switch action type case, if it is add item, then return add item reducer of current state and action. Case, mark item as complete. Okay, then case, mark item as incomplete.
So
Same thing.
Sagar, in that case, do we really need if condition in our methods?
Yeah, we normally don't need it. But
Right.
yeah, but just if we don't need it, you're right. Okay.
Because we will be adding a default in the switch, which will return the current state anyway. So if type doesn't match, it will return the current state. So we can save, else condition from each of the function. We don't need it.
Yeah, we don't need that. You're right.
Okay.
Okay. Right. So let me just put all of these cases here. 6 were there, 5 are here. Okay. So mark item as complete, mark item as incomplete. Remove item, edit item, and move item. So this is correct. Remove item, edit item, move item. Okay, and default is current state. Okay, we don't need this current state anymore because we don't want to run this as a script now. We just want to export this reducer, make this into a module. Okay, so as you can see, I have neatly documented the action type and also the object here for reference that helped me write this code. So usually I'm into a habit of first denoting all the actions, their structure, and then implementing this. So what did we do here? We wrote this to do app. So let's export this to do app. Right? So this is our reducer for the to do application. Now let's use that inside Redux here. So first let's install not dev and we can install Redux. Okay. And so the first thing is import create store from Redux const store equals create store to do app and the initial state. So in my initial state, the items is empty list. Okay, so what I'd like to do is I'd like to dispatch actions to this. So store.dispatch and I can give the action. So type is add item, payload is item one. So I'll add this a little while later. So set timeout. Let's say 5 seconds later. Okay, so 5 seconds later, it's going to dispatch an action to the store. And then we are going to say store.subscribe and then new state equals store.get state console.log new state. Okay, and I'll also log the old state, initial state. Right? So we can create a store using the reducer and using the initial state. Then we can dispatch actions using store.dispatch and we can subscribe to any changes in the state using store.subscribe. So this function, it doesn't take any arguments. This function is called every time the state change happens. Okay, and we can grab the new state from here and log it. So initially, the initial state would come uh, with an empty items, and then 5 seconds later, this should get printed in the browser's console. Okay, so let's see how this works. So we have to import to do app. How do I get rid of this? This is coming for the first time. Suddenly my errors started coming in like, okay, crosses. Right. So import to do app from /to do app. Okay. To do app does not contain a default export. right? So this executed and we got the initial state, and 5 seconds later we got the updated state. Okay, so basically this is the interface for our store. Okay, so create store, reducer, initial state will give us an instance of store. Using store.dispatch, we can dispatch the actions, which internally calls the proper reducer, and then we subscribe to changes in the state. And whenever the change happens, we are logging the updated state here. Okay. Now let's quickly create a React.js functional component which takes this items and which basically renders it properly. Okay. So I'm going to create a new item, call this to-do list.js. Okay. So import React, comma, component from React, export default class to-do list extends component, render. And what are we rendering here? We are rendering. So what do we receive as input here? We are going to receive, let's write this code so it becomes clear. So this to-do list is something which we can render here. So initial state, let me put one item so that I can check this component first. Later I'll add item 2. Okay, I have to give a key here. Okay, so this is coming. Now, one of the quickest way to actually use this component, see, this component doesn't have any state. So actually I can export default function to-do list of props instead of exporting a class. Okay, and instead of this dot props, I can simply say props.items. Then we don't need a render at all. All we need is a return component. Right, so this is a stateless component. So if we want to make use of the stateless component inside React.js, then what we could do is we could call render every time the state gets updated. Okay, so instead of, yeah, I guess this should work. So 5 seconds later, automatically another item should get added ideally. Okay, so there you go, right? So what are we doing? Every time we are subscribing, we are replacing the to-do list instance with a new instance of to-do list. Okay, with an updated list of items, right? This is a very simplistic implementation. It doesn't utilize all the fancy features of React.js. It's something very basic. Okay, so let me just wait here for take some of your questions. If you have any questions? Okay. Uh, I'm just a little surprised, because the last time we had a session on reducers or Redux, it was really confusing for the participants. So I just want to make sure is it clear? Is it fine? Or is there some part of this session which you would want me to repeat, or is it perfectly okay? Yeah, probably the next session, not today. Okay, I think first let's get the hang of writing immutable reducers. So today's assignment is primarily going to be around writing reducers and also the test cases for those. Unit test cases, not React.js test cases. Okay, so I'm assuming that you have understood it quite well. How large data can we store? So I don't have a direct answer for this question, but I'll give you an analogy for this. How large data we can store is basically the state is being maintained in memory, right? So how big a data would you want to store uh, as part of your state? How much can you store? So if you actually look at if you actually look at modern day applications, unless you're working with a streaming application with lots and lots of data being streamed to you, uh, like if it's not any kind of financial or any such kind of data, you can store quite a lot of data. Even if you say something like 10 KB, 10 KB is lot of data when it comes to applications, right? And storing 10 KB in memory it's not uh, something which is unthinkable, right? So of course, one thing which we have to keep in mind is about memory leaks. So for instance, if you are taking the state and constantly you are maintaining an array of all the states which the user has maintained so far, so that you want to provide control Z or undo capabilities inside your applications. And your state is actually quite huge. And every time the state is changing, we are creating a new instance of it, right? That will very quickly eat up your memory if your state is quite huge and if you have lots and lots of events which are constantly changing the state. So when you're implementing things like undo, redo, this kind of functionality, you have to provide some cap somewhere saying that you can undo only up to 10 states, uh, 10 states, okay? Or maybe 50 states or 100 states, depending on how big your state is, okay? but don't support more than that. So those are basically how we need to address the problem of memory leaks or taking up a lot of memory within the browser. But as long as the a single state is concerned, we are covered from the point of view that it can maintain lots of data actually. So 10 KB, the example which I took, even 10 KB is very huge. Okay, so from that point of view, we need not be worried about data, but uh, we have to be worried about memory leaks. Okay, if we continuously keep pushing things in an array and never clearing things from an array, then that becomes something very complicated. Okay, and another way in which we can look at this problem is uh, maybe the entire state need not be brought down to the client side application. Okay, only some part of the state could be brought down to the client application. The remaining could stay there on the server itself, and whenever we need more data, then we can get it from the server. So for instance, if your to-do list has if this is something like a product backlog for your software development, and you have lots and lots of action items in your product backlog, you'll probably have several hundreds of items in the product backlog, right? It doesn't make sense to load all of it onto the user interface. Okay, keep it on the server. Only the data which the user can see, only that information you can bring it down to the client side. Okay, so as a general rule of thumb, only load the data that the user can see. Okay, if there is lots of data that the user cannot see, then there is no point maintaining a state for that or maintaining it inside the state. Okay, so just the data which the user can see, maybe some cache data. If the user keeps moving back and forth between pages or between components, then you can maintain the information of those data within your state. Okay, so I don't have a direct answer, Brajesh, but I hope this gives you some sense of what data we can, how much data we can store. Okay, so Anurag, apart from render function, which lifecycle function triggers on state change? So for this, let's look at the React.js documentation. For state and life cycle. Okay, so here you have what here. Let's see. Yeah. So what did I do? I went to advanced guides. No, sorry. I went to main concepts, state and life cycle, and then there is a detailed component API reference. Okay. So I opened this, and here you can see the component life cycle, and for mounting what is called, and for updating what is called, unmounting what is called. Okay. So updating, these are the different methods which get called. Okay, Anurag? Yeah. Okay, so let me quickly move on to the next part where wherein we will design this using test cases, okay, but for our Trello application. So let me create a directory called test. Which includes my uh, test case for to do app.js. Okay, so if I look at package.json, no, I'm not sure exactly what test framework they use, but let's try it out. So describe uh, to do app, which takes a function. It should add items. Okay, so how do you write a test case for this? Const current state equals, so instantiate a current state where we are going to have a list of items, right? And this items is going to have ID of, let's say, 0, and text of, let's say, item 1, and is complete false, right? Let's add one more item, ID 1, text item 2 is complete true. Okay, so this is our current state. Action equals add item, payload will include text, which is item 3. Okay, right? And then we are going to say uh, to do app, then we are going to, yeah, we can say to do app of current state and action. Okay, so let me just quickly look up create React apps convention about how to write test cases. Usually it is written beside the component itself, but if I write it somewhere else, then how do I uh, get it to work is the question. Okay, so let's try and name this .test.js. No, I think it looks for the SRC directory under the SRC top level. Yeah, so they recommend that to put this beside the test actual code. So let's move this test slash to do app.test.js to SRC directory. Okay, and now let's try. Okay, it's passing. We didn't write any assertion, so definitely it'll pass. Right? So what assertions are assertion libraries present here? Expect is present apparently. Okay, expect and chat. Expect is present. So expect new state to deep equal, or expect new state dot items to have length. Okay, all expect matches are documented here. To have length number. Expect to have length of 3, right? Let's see if this passes. Okay, and let's say I say 2, it should fail. It's still passing, so obviously this part is not working. Okay, so let me quickly install Chai and work with Chai. Okay, so why is this not checking new state dot item should be instance of array? Okay, so since we are running out of time, what I'll do is I will share a sample test case and a sample project with you. So this will come along with the assignment boilerplate, okay, which will be released today in the first half, right? So along with that, you will have one sample test case for a to-do application. So this will already be there. So what you will need to do as part of the assignment is you will first have to write a reducer for your Trello application. Okay, so just like we have written the reducer for the to-do application. So you should write an example for the Trello application. And doing that, you have to identify all of the action types and the payload that is required for each of these actions and implement it. And secondly, you will also have to write a test case for your to-do application here in the test.js file. So each one of them, for every action, there has to be at least one test case. Okay. So this is what will be part of your assignment for this week. Let me give it one last try. Should be instance of array. Oh, I think I've been changing it in the wrong place. Now it's passing. Okay. What happened when I moved the file? This file was a deleted version in the test directory. That was what I was changing. That's why it's not taking effect. Okay. So what should we do? New state. So this is one assertion which we wrote. I will say add deep equal. We will give the exact same object that's present here. Okay, but we don't know the ID here of the last item. Okay, so without knowing the ID, it's difficult to write a deep equal part. So have a length of 3 and new state dot items of 2 dot text should be equal to our action dot payload dot text, right? So this is also passive. If I write action dot payload dot text, it's not equal. Okay, so we are checking that this new state should be instance of array and have length of 3, and new state of items 2 dot text should be equal to action dot payload dot text, right? So this is a simple test case for our adding of items. It's a unit test case for this reducer, right? Similarly, we have to write an integration, a unit test for each one of the actions. This is going to be the assignment for this week. Okay, and make sure to use immutable operations inside your reducer. Don't use any mutable operations. Don't use dot push. Don't use object dot something equals. They are not allowed, right? So this is just for practice so that we get used to writing these reducers very quickly. Okay. So let's see. Yeah, so Soumya, yeah, let's address this part now. So basically, thanks for reminding Soumya. I had actually forgotten about it. So let's just cover this. See, what Soumya is saying is, instead of writing something like this, object.assign, we wrote an add item. No, instead of writing object.assign like this, we can also use this operation. We can also use something like a spread operator in objects. Okay, so then we have triple dot current state, and then we have items, new items. Okay, so even when I do this, my test case is passing. Okay, so suppose I don't include this item, then test case should fail. Let's try that. Okay, so my test case is failing. So this is also another way in which we can actually write the code instead of using object.assign. So Soumya is asking, why didn't we write it? Why can't we write it? So we can write it, no problem writing. Only thing is, see, when we are talking about JavaScript, then we normally follow some standard. So there will be ES6, ES7, ES8, which are standards in JavaScript, right? And there are certain new features which are yet to be released. They are in draft stage. So draft stage 1, draft stage 0, and so on. Okay, so this particular feature is not part of any of the standard. It's not part of any of the draft stages. Okay, in fact, the only reason why this is working, it's also not supported by Node.js or Babel by default in any of these standards. Okay, the only reason why this is working is because this create React app includes the transpilation for this particular feature. Okay. Uh, it's called something. I don't remember the name for it. I'll find it and I'll share the proper name for this feature within on Slack. So when you're configuring Babel, then you have to include a preset for this particular feature alone. Okay, which is in addition to any other presets that you're giving. So this is not common in normal JavaScript projects, but within React.js, this is very, very common, specifically because React.js and Redux work very well together. Okay, so I wanted you to be familiar with creating these objects, even in an environment where this transpilation is not included. Okay, that's the reason why I first introduce you to this notation of creating new objects. Okay, what I would suggest is I would recommend you to practice both. You should be familiar with both of these. Okay, so initial versions, probably if you could use this object.assign for this assignment, then it will be good. From the next assignment, let's refactor the exact same code with this part, with this notation. Okay, so is that fine, Soumya? Does that answer your question? Yeah. Any more questions? We could take it up on Slack. So we'll release the assignment today, the next part of the assignment. Okay. Yeah. So thanks, guys. That's all for today's session. Thank you. The next session is going to be on Thursday. That is the 3rd of January, the new year. Okay. So thank you, everybody.